3.3 is rate of change in slope. First, let's talk about slope. The slope of a line determines the steepness of the line, how steep it is. We have slopes that rise from left to right. If it goes upward like that, or like this from left to right, if it is going upward, it is a positive slope. If it's going downward from left to right, and again, it doesn't matter how steep it is, these are all negative slopes. Example 4a, find the slope of the line that goes through -2, 0, and 1, 5. First, we need to know the formula. The formula for slope is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the subscripts are just distinguished between point 1 and point B. You're always going to have 2 points, and every point has an x and y. So that's what the subscript, this is x1, this is y1, this is x2, this is y2. It doesn't matter which one you identify the point. This could be, it doesn't matter, either one. So what I like to do is underneath the points, I'm going to rewrite the points over here so I can write. I give the first point, I label that my x2 and y2, and my second point x1, y1, just because it flows into the formula a little bit easier. So y2 is 0 minus y1 is 5 over x2 is -2 minus x1 is 1. 0 minus 5 is a -5. -2 and a -1 is a -3. Negative divided by negative is a positive 5/3. Now, what if, I'm going to rewrite the points, and I'm going to give the first one x1, y1, and the second x2, y2. Let's watch as it points into the formula. Now this time your y2 is 5 minus your y1 is 0 over your x2 is 1 minus your x1 is a -2. Well, minus a negative turns into plus a positive. 5 minus 0 is 5 over 1 plus 2 is 3. So it doesn't matter which way you go, which point you give your x1 and y1, you will get the same answer. Now let's plot these 2 points on a coordinate plane. -2, 0 is right here, and 1, 5 I'm going to connect my lines. Now, if you're given a graph, you can calculate the slope by doing rise over run. If it's positive, you go up. If it's negative, you go down. Run, that would mean to the right if it's positive, or if it's negative, to the left. So let's put our pencil on one point, and we're going to go rise up 5 and to the right 3. So your slope is 5 over 3. So there's 2 different ways of calculating the slope. If you're given the 2 points, you want to calculate it using the formula. But if you're given the graph, you want to calculate it by doing rise over run. And you can always do it a second time. Go up 5 and over 3. And you would land on the line every single time. Example B, let me back up for just a minute. This is a positive slope, and it is going upward, so you can tell that it's a positive slope. Example B, find the slope passing through -3, 4, and 2, -3. State whether it's positive or negative. First thing we must do is we must write our formula. Every single time you use a formula, you write the formula down, and then you plug it into the formula. I'm going to give the first point x2, y2, and the second one x1, y1. It does not matter. That's just the way I do it because it flows into the formula. So my y2 is 4 minus a -3, which turns into plus a +3, over -3 minus 2. 4 plus 3 is 7, over -3 and a -2 is a -5. Now we never leave a negative in the bottom. It's a -7/5. Never leave a negative in the bottom. Show that the whole fraction is a negative. You put it in the numerator or in front. Now let's go ahead and plot these 2 points and see if by calculating rise over run, let me rewrite this, it's -7/5. Okay, it doesn't matter which point. If you want to start at the top point and you're going to go down 1, 2, 3, 4, 5, 6, 7. So down 7 because the negative is 7 and to the right 5. And you land on the point. Now, if you started at the bottom point and you went up 7 and then backwards 5, backwards would be negative. So the point that I'm trying to make is that you can put the negative with the 7 or the 5, but you cannot put it with both. And we have to state whether it's a positive or a negative slope. It is a negative slope because there's a negative. And also look at the line. It is going downward. So a downward slope, a downward line means it's a negative slope. 4C, find the slope through these 2 points. Again, my formula is m equals y2 minus y1 over x2 minus x1. Always write the formula down. I'm going to give the first point x2, y2, and the second one x1, y1. Just because it flows into the formula easier. y2 is -1 minus y1 is a -1, and minus a negative turns into plus a +1 over -3 minus 2. Now -1 plus 1 is 0 over -5. And 0 divided by anything is 0. Anytime you have 0 in the numerator, it is always 0. And you must write equals 0. If you leave it 0 over -5, I'm going to mark it wrong. The final answer is 0. Now let's see. Let's plot these 2 points and see what we get. Okay, when we plot these 2 points, we get a horizontal line. So we can come to a conclusion. All horizontal lines have a 0 slope. Example 4D, find the slope passing through 2, 4, and 2, 1. Again, I'm going to write the formula down. Always write the formula down. I'm going to give the first one my x2, y2, and my second x1, y1. So my y2 is 4 minus 1 over 2 minus 2. 4 minus 1 is 3 over 0. Now, remember, you cannot have 0 in the denominator. If you ever have 0 in the denominator, that is undefined. Or you can say no slope. So let's plot these 2 points and see what we get from that. When we plot these 2 points, we get a vertical line. So we can come to a conclusion. All vertical lines have an undefined or no slope. You can call it either one. Some books refer to it as undefined, some books refer to it as no slope. So you need to know both ways. Example 5. If we're going to find the slope, m is equal to y2 minus y1 over x2 minus x1. Okay, my y2 is going to be 4 minus a negative 3, which is plus 3, over negative 2 minus a negative 2, which is plus 2. So that's 7 over 0. If we leave it 7 over 0, it will be wrong. The answer is no slope, or you could say undefined. Now look at the directions. It says state whether it's a positive or a negative slope. When it's no slope or an undefined slope, or if it's a horizontal slope, it's no such thing as positive or negative slope. Okay, now remember, what does an undefined slope give us? A vertical line. So let's plot these 2 points and make sure that is what they give you. And it is a vertical line. So this is something that you're just going to have to memorize. A horizontal line, the slope is 0. Vertical line, no slope. Rate of change is basically the same thing as finding the slope. It is the change of y's, because remember the formula was y2 minus y1 over x2 minus x1. So change means change from one y value to the next y value, which is the same thing as subtraction. Example 1, use the table to find the rate of change. Well, you can do it one of two ways. You can pick 2 points, find the slope using the formula, y2. You could do 78 or 156, it doesn't matter. 78 minus 156 over 2 minus 4. 78 minus 156 is a negative 78 over 2 minus 4 is a negative 2, which is 78 divided by 2 is a positive 39. So your slope is 39. Now, you could also, what you could do when you have a table is go from one point to the next. Here's another way of doing this. 78 to 156, it was a change of 78. From 156 to 234 is also a change of 78. Over here on your x values, from 2 to 4 is a change of 2. From 4 to 6 is a change of 2. So that's another way how you could get 78 over 2, which is 39. And rate of change, that means every computer game, if you will look, this is X, stands for the number of computer games, and the total cost was Y. So it looks to me like every single computer game cost $39. So that is the rate of change. Usually when you're dealing with money, it's referred to as rate of change and not slope. Example 3, determine whether each function is linear. If it is a linear function, then the slope from one point to the next is the exact same. The rate of the slope change in your y's and then your change over your x's is the exact same thing. So from negative 6 to negative 8, we subtracted 2. From negative 8 to negative 10, we subtracted 2. From negative 10 to negative 12, we subtracted 2. And from negative 12 to negative 14, we subtracted 2. So that is equal. It was the exact same thing. It was constant. So let's look at our x's. From 1 to 4, we added 3. From 4 to 7, we added 3. From 7 to 10, we added 3. From 10 to 13, we added 3. So our change in our y's over the change of our x was negative 2 over 3. So it was consistent, so it is a linear function. Let's look at example B. 10 to 12, we added 2. 12 to 14, we added 4. 16 to 18, we added 2. 18 to 22, we added 4. We can stop right here because they have to be the exact same thing. So this is not a linear function. And not linear means it will not make a straight line. Example 6a, find the value of r so that the line through 1, 4 and negative 5r has a slope of 1/3. Okay, in this problem, we're going to use our formula, m equals y2 minus y1 over x2 minus x1. But in this problem, they gave us our slope. What is missing is the y. So let's plug in what we know into the formula. Slope is 1/3. y2, again, I'm going to give the first point x2, y2, and the second x1, y1. y2 is 4 minus our y1, we don't know, it's r, over x2 is 1 minus x1 is a negative 5, so that's minus a negative 5, which is plus 5. Okay, now look right here. What does this look like? This looks like a proportion. Now right here, 1 plus 5 is 6. I could rewrite it if I wanted to. You know what, I'm going to rewrite it right next to it because I'm running out of room. Now this is a proportion. We know how to solve proportions. I'm going to cross multiply. 3 times 4 minus r, I need to put the 4 minus r in parentheses, is equal to 1 times 6 is 6. Now to solve, I'm going to do the distributive property. I'm going to subtract 12 on both sides. So that's negative 3r is equal to negative 6. Divide by negative 3, and I get r is equal to 2. So that is the point negative 5, 2. So r is 2. To check this, I could find the slope of these 2 points, and when I do find the slope of these 2 points, I better get 1/3. Example 6a, find the value of r so that the line goes through negative 2, 6, and r negative 4, and has a slope of negative 5. So once again, I'm going to write my formula down. Let's plug in what we know. M is negative 5. Now because that's a fraction on the right side, I'm going to go ahead and put that negative 5 over 1. My x2 is 6 minus a negative 4, which is plus 4, over negative 2 minus r. Now right here, 6 plus 4, I'm going to rewrite that to say negative 5 over 1 is equal to 10 over negative 2 minus r. I am going to cross multiply. Negative 5, I'm going to do this over here because I'm running out of room. Negative 5 over negative 2, or times negative 2 minus r, is equal to 1 times 10 is 10. Do the distributive property, that's 10. Be careful about your negatives. Plus 5r is equal to 10. Subtract 10 on both sides. So that's 5r is equal to 0. Divide both sides by 5. R, 0 divided by anything is 0. So my point is 0. So this point turns into be 0, negative 4. Again, I could check this by finding the slope of these 2 points, and when I find the slope of these 2 points, I better get negative 5. Your assignment is page 176, even numbers 14 through 22, all 24 through 39. The next class day will have a quiz over 3.1 to 3.3. If you notice, we skipped 3.2.